Hi, good day everyone. So this would be the continuation of our discussion. So we've already discussed introduction to biochemistry. It includes definition of biochemistry and its importance. We've already also reviewed some terminologies pertaining to chemistry. So with that, let's proceed to another topic, which is the very first macromolecules or biomolecules inside your body, which is carbohydrates. So today we will be discussing the definition, not only the definition but also its composition. But before we will be discussing its definition and its composition, let's unlock first some terminologies. So we have here a list of terminologies that we should unlock. First is functional group. Second would be, now let's move forward to another slide, which is aldehyde. So aldehyde is an any of a class of organic compounds in which a carbon atom shares a double bond with a single bond with another atom or group of atom. So aldehydes, or the structure of aldehydes, design or designated are in general chemical formulas and structure diagrams. So as you can see in the illustration below, the double bond between carbon and oxygen is characteristic of all aldehydes, and it is known as the carbonyl group. So why it is known a carbonyl group? Because the main function of aldehyde is to share a carbon atom to a double bond with an oxygen atom and a single bond with an hydrogen atom. So always remember why aldehyde is said to be a carbonyl group, because it shares a carbon atom. So now what is aldehyde and its uses? So of course, in carbonyl group or in carbonyl compound, there are so-called industrial use. When we say industrial use, other aldehydes or aldehydes of industrial significance, or the importance of aldehydes in the industrial use is actually it is used as a solvents, perfumes, and flavoring agent. So that was the use of aldehydes in industrial aspect. So but in biochemistry, aldehydes, or in the structure of aldehydes, it focuses on on sharing carbon atoms. That is why it's called carbonyl group. So in the slides, it explains the structure of aldehydes. So in formaldehydes, the simplest aldehyde is the carbonyl group, which is the carbonyl group is bonded to two hydrogen atoms. In all other aldehydes, the carbonyl group is bonded to one hydrogen and one carbon group. In condensed structural formulas, the carbonyl group of an aldehyde is commonly represented as CHO. So using this convention, the formula of formaldehyde is HCHO, and that of acetaldehyde is CH3CHO. So that was the chemical formula for formaldehyde as an aldehyde and acetaldehyde as an aldehyde. So in the structure itself, when we say aldehyde, it consisting of a carbonyl center. So when we say carbonyl center, a carbon double bonded to an oxygen, with the carbon atom also bonded to hydrogen and any generic alkyl or side chain, which is called R group. So that's why I've already stated or explained a while ago that in aldehyde, it represented as an R group. So as you can see below again in the illustration, it shows the structural formula or the chemical formula for, formula, because the chemical formula of the formaldehyde is HCHO, and the chemical formula for acetaldehyde is CH3CHO. Okay, so the structural formula of it is in below. So as you can see in the illustration, we have oxygen is double bonded into hydrogen and carbon, two hydrogen and carbon, while in acetaldehyde, it's actually double bonded with oxygen with the 3 carbon hydrogen, and of course with another carbon hydrogen. So that was the structure of aldehydes. Let's move forward to another slide. So now since we've already done discussing aldehydes, so please, if you have questions and clarification, you can leave that in our GC. So now let's discuss to another functional group in carbohydrates, which is ketone. So ketone is an organic compound containing a carbonyl group. So the same with aldehyde, ketone is also a carbonyl group. So the similarities lang between aldehyde and ketone is that aldehyde is only shared carbon atom in a single band to oxygen and a single band also to a nitrogen. But in ketone naman, it shared double band to two hydrocarbon groups made by oxidizing secondary alcohol. So that was the differences between aldehydes. Again, in aldehydes, it actually shared a carbon atoms in a double band with an oxygen and a single band with a nitrogen atom. So that was the difference ha. Kasi sa carbon atom, again, yung double band niya nakadikit lang or nakakombine sa oxygen. And it produces a single band to the hydrogen. As you can see in the illustration below, yung double band niya na focus sa oxygen, but also the carbon of the aldehydes shared single bond in an hydrogen. Comparing it to the ketone naman shared double band. Double band to what? To two hydrocarbon groups made by oxidizing. Aside from its structure, ketone also called as a highly reactive functional group, to which they are closely related to aldehyde. Why? Because aldehyde is less than highly reactive, or less than produces a highly reactive than the ketones. So why I said that ketones is a highly reactive than aldehydes? Why? Because ketones is readily undergo a wide variety of chemical reactions. So that is why it explains that the ketones are highly reactive than the aldehydes. So if you have no more questions with this slide, let's move forward to another slide. So aldehydes and ketones are classes of organic compounds that contain a carbonyl group. So as I've said, the similarities of aldehydes and ketones are they are both functional group pertaining or producing or includes in the group so-called carbonyl group. Why? Because they both produces or they both shares a double bond carbon. Okay, since aldehyde and ketones are similar in producing or in sharing a carbon atom, what makes them different? So can you figure out by the structure what makes the different between the aldehydes and ketones? So always remember that the different of it is only the hydrogen. Why? Because aldehyde contains a hydrogen atom connected to its carbonyl group. As you can see in the illustration to the aldehyde, carbonyl group is actually attached in the hydrogen, while ketone does not have an hydrogen atom attached. The difference between aldehyde and ketone. So always remember by its structure that aldehydes is contain or attach a hydrogen atom connected to its carbonyl group, while ketone does not have a hydrogen atom attached. But eventually, in naming a ketone in our next topic or in our further topic in this lesson, we can eventually know that if the structure or if the compound has a ketone, how by its suffix. If the name of the compound has a suffix ending of the chemical name, which is called as one or one, eventually you can be sure that that compound has a present of which is called ketone. So ganyan lang, yan lang dyan natin makikita the differences, or if the compound has a ketone kapag sa suffix name niya. So I will be literally explaining that furthermore in our next topic. So if there is no clarification in this slide, let's move forward to another slide. So now let's unlock another terminology which is called as polyhydroxy. Polyhydroxy is a chemical compound containing two or more hydroxyl group per molecule. So hydroxyl group are simple structure consisting of an oxygen atom with two ion pairs bonded to an hydrogen atom. So the function also of hydroxyl groups, it is able to form hydrogen bonds with the water. So as you can see in the illustration, we also have the aldehyde group combining two hydroxyl group. So the chemical formula for this illustration is C6H12O6. And also remember that in hydroxyl group, the structure always attach an OH, kasi OH will be the representation of hydroxyl group in a certain structure. Going back to another topic that we've been discussing, which is carbonyl group, the differences between the carbonyl group and hydroxyl group. Carbonyl group is the group that is actually sharing a carbon, while hydroxyl group is a group that bonded or can easily be bonded to water, and it's actually consisting of a simple structure called an oxygen atom with two ion pairs bonded to an hydrogen atom. So that was the differences between carbonyl group and hydroxyl group. And for the structural of polyhydroxy, again, it's attached, or the structure of it is not only attached by the hydroxyl group, but also it attached in the terminal of the structure, which is called as aldehyde. You can see naman that in the terminal of the structure, you can be found the aldehyde group, which has a carbon, double bond with the oxygen, and single bond with the hydrogen, connecting to the hydroxyl group with a representation of OH. And in the terminal of the polyhydroxy, it represented also the chemical formula of glucose. So that was the structure raw formula for polyhydroxy. So let's move forward to another slide. So polyhydroxy aldehydes and ketones. So the key differences between polyhydroxy aldehydes and polyhydroxy ketone is that polyhydroxy aldehydes contain an aldehyde group with many OH group, whereas polyhydroxy ketones contain a ketone group with many OH group. So as you can see, the differences lang kasi ng polyhydroxy, itong illustration na pinakita ko dito, it is the representation of polyhydroxy aldehyde. Why? Because in the terminal of it, you can be found the aldehyde group. The differences lang, if we compare it to polyhydroxy ketone, is the terminal of the structure is not aldehyde, but a ketone group na. So that was the difference between the polyhydroxy aldehyde and polyhydroxy ketones. Again, in polyhydroxy aldehyde, the terminal of the structure, you can be found the carbon that can be attached to the double bond oxygen and the single bond hydrogen. Whereas the polyhydroxy ketone, you can be found the formula of it, which is the double bond of the carbon is attached to hydrocarbon with the oxidizing element. So that was the differences between the polyhydroxy aldehydes and the polyhydroxy ketones. Dito lang siya nagdi-differ sa terminal niya lang, as you can see in this illustration. Yung terminal lang, yung sa above lang ng structure, dyan lang nagdi-differ ang polyhydroxy aldehyde and polyhydroxy ketone. Okay, let's move forward to another slide. So the term polyhydroxy aldehydes and the term polyhydroxy ketones describe the structure of carbohydrates. Yes, that is why I've said in a functional group, we will be focusing on ketones and aldehydes because it can describe, or it can explains the structure of carbohydrates. Both of these compounds have a number of hydroxyl group, which is OH. Sabi ko nga, the representation of hydroxyl group, is an OH group, and the carbonyl group, either aldehydes or ketone group. Kasi yun nga, that the similarities of ketone and aldehyde is it is both carbonyl group, but the differences of it is aldehyde attach or contain hydrogen, while ketone does not attach or did not attach a certain hydrogen. Wala siyang hydrogen ang ketone comparing to aldehyde na merong naka-attach na hydrogen. Okay? Next to that, what are polyhydroxy aldehydes? So, these are the answer. Polyhydroxy aldehydes are organic compounds containing many hydroxyl group and an aldehyde group. Here, the carbonyl group occurs at the terminal carbon atom. We call them aldoses. So, furthermore, this carbon atom of the aldehyde group can combine with one of the hydroxyl group when the compound is the aqueous solution to form a silic compound that we call it hemiacetal. Okay? So, yun na nga, yung sinasabi ko in this formula. Dito, itong structural formula na ito yung pinapakita ng aldehyde group. So, as you can see, yung terminal or yung the above of the structure is aldehyde. So, aldehyde is actually attached to a many hydroxyl group. Why? In this formula or in this structural formula, we can found 3 hydroxyl group. We have 3 OH in this area. So, this was the example of the illustration in polyhydroxy aldehydes. So, in that terminal of carbon atom, yung naka-attach above ng terminal ng structural ng polyhydroxy aldehydes, anong tawag doon? It is called as aldoses or aldosas. Okay, and aside from that, it's said that the carbon atom in polyhydroxy aldehyde is actually combined with one hydroxyl groups. So, when the compound is an aqueous solution, it can be formed as a silic compound that we call it hemiacetal. So, that was the definition of polyhydroxy aldehyde. So, always remember, wag maguluhan that the differences between the polyhydroxy aldehyde and the polyhydroxy ketone is their what? Their terminal. Yung above ng structural form nila, kapag yung terminal nila makita mo yung formula ng aldehyde that it can attach with the hydroxyl group, meaning it is polyhydroxy aldehyde. But if you can see that the terminal of the structure is a ketone that attached in hydroxyl group, it is called as polyhydroxy ketone. So, yan lang yung differences niya between the two. So, let's move forward with the illustration. So, as you can see, there are illustration here that in aldoses, here, nakikita nyo nga yung sinasabi ko na sa above terminal niya, itong nandito sa pinakataas, it called as aldoses. But this is an example of polyhydroxy aldehyde. So let's give a differences between the structural formula for aldoses and ketosis. These are the example. We have glyceraldehyde, we have ribose, glucose, and galactose. As you can see, it is called as aldehyde in the end of the suffix name of the compound, or it is the end of OSE in the suffix name of the compound. Why? Because there are attached aldoses, or the terminal of the structure of the structure has attached aldoses or aldehyde. Kaya siya, the suffix ending niya is aldehyde or OSE for it. So, we also have a ketosis here in the lower part of the illustration, the hydroxyacetone and ribulose and fructose. As I've said, ketosis or ketosis is actually called in the terminal of the polyhydroxy ketone. Yung pinaka-above terminal niya, ang tinatawag doon ay ketosis. Kasi you can eventually know the structure or the structure of the ketone in that terminal. So, ito yung example niya, yung tatlo, dihydroxyacetone. As I've said, makakakita or makikita mo na yung ketone sa name pa lang ng compound kapag may the suffix or the ending of it is ONE. So, that was the differences between the aldoses, the structural formula of aldoses and ketosis. Okay, so let's proceed to another slide. So, if there is a polyhydroxy aldehyde, there is also a polyhydroxy ketones. As I've said kanina, na-explain ko na that the differences between polyhydroxy aldehyde and polyhydroxy ketone is that the terminal of polyhydroxy ketone is a ketone formula. So, To be exact, to explain it further, when we say polyhydroxy ketones, these are the organic compounds that containing many hydroxyl group and ketone group. Here, the carbonyl group occurs at the second carbon atom from the terminal of the molecule. We call these compounds as ketosis. If aldosis can be presented in the terminal or yung tutok or yung the above structural form ng isang polyhydroxy aldehyde, ang makikita mo naman ang ketosis in the middle or in the second carbon atom from the terminal of the molecule. So from the above of the molecule or from the above of the structure in polyhydroxy ketone, you can see the ketosis in the second carbon atom. Same as aldosis, these compounds also can be combined with hydroxyl. Okay, yun na nga yung sinasabi ko na same as aldosis na the similarities lang nila is they can be both combined with the hydroxyl group of the same molecule, removing a water molecule to form a cyclic compound, which is hemiketal. So in polyhydroxy aldehyde, it's called hemiacetal. In polyhydroxy ketone, it is called hemiketal. So let's proceed to another slide. So another slide is the representation of an illustration, which is ketose. So as you can see, the ketosis can be found in the second carbon. Andito yung na-highlighted sa structure, yan yung ketose. So from the aldosis and the ketosis, as you can see that aldosis can be found in the terminal. Makikita mo yung terminal ng yung mga highlighted terminal of the of the aldosis structure, yung dito sa pinakataas, yan makikita mo sa first above carbon naka-attach na si aldosis. Comparing to ketosis, sa second carbon lang pa siya naka-attach. So yan yung differences between the two, between the aldosis and ketosis. Aldosis is attached now into the above or the first carbon that represented in the structure, while the ketosis can be found in the second carbon of the structure. So that was the structural formula for ketosis and aldosis. So let's now move forward. So these are actually similarities or summarization, similarities and differences, or the summarization of polyhydroxy aldehydes versus polyhydroxy ketone. So for the definition, polyhydroxy aldehyde are organic compounds containing many hydroxyl group, as I've said, and aldehyde group. And while comparing it to ketone, polyhydroxy ketones are the organic compounds containing many hydroxyl group and ketone group. So yan lang yung differences nila ha, that in a structural formula again, na you can see if that compound, or you can see if that structure is a polyhydroxy aldehyde if the terminal of it has you can be found the aldehyde formula. Comparing it to polyhydroxy ketone, masasabi mo naman na polyhydroxy ketone yung isang compound or isang structure kapag ang nakakita mo sa terminal naman niya ay ang ketone formula. So in functional group, an aldehyde group and ketone group. So, in polyhydroxy versus polyhydroxy ketone, polyhydroxy aldehyde versus polyhydroxy ketone, yung functional group na makikita nyo ay aldehyde group for the polyhydroxy aldehyde, and for the polyhydroxy ketone, we have ketone group. In carbonyl group, again, aldehydes or polyhydroxy aldehydes occurs at the terminal of the molecule. When we say at the terminal of the molecule, makikita nyo siya sa above or the first carbon in the structure. While the polyhydroxy ketone, makikita nyo siya or it occurs in the second carbon, yung pangalawang carbon ng atom from the terminal or from its structure. So our other name for the polyhydroxy aldehydes and polyhydroxy ketone, for the polyhydroxy aldehydes, it is called as aldosis, and for the polyhydroxy ketone, it is called as ketosis. For the cyclic compound, we have hemiacetal and hemiketal. Hemiacetal for polyhydroxy aldehyde and hemiketal for polyhydroxy ketone. So for reaction to Cellulonophtase. The cellulonophtase is actually a reagent for testing a carbohydrates. So in polyhydroxy aldehydes, it reacts slowly and gives a pink coloration. And while in a polyhydroxy ketone, it reacts quickly and gives a dark red coloration. So always remember that cellulonophtase is one of the tests that you can be used as a reagent if you want to test if a certain compound is a carbohydrates. So the differences lang in the coloration between polyhydroxy aldehydes and polyhydroxy ketone is sa polyhydroxy aldehyde, yung kalalabasan na color is pink, while in polyhydroxy ketone, the color of it will be dark red. So for example, in polyhydroxy aldehyde, we have monosaccharide and such as glucose, while in polyhydroxy ketone, we have a monosaccharide such as the dihydroxy acetone. Okay, so that was the differences between the example of polyhydroxy aldehyde and polyhydroxy ketone. So let's move forward to another slide. So I hope that you've already know the differences between polyhydroxy aldehyde and polyhydroxy ketone, and you already know the differences between aldehyde and ketone. So let's move forward. So that was the end of the terminologies that we can be found in carbohydrates, in the composition of carbohydrates. So this is the end of our discussion for the continuation of lesson 1. So if you have a questions, clarifications, you can leave now. You can leave your questions in our GC or you can PM me in Messenger. Thank you very much and God bless.